All right, let's take a look at the lab. Temperature versus the rate of dissolving. First, it shows a picture of solid NaCl. The blue spheres are the sodium cations, and the green spheres are the chloride anions. So then they show you a picture of some water molecules, and you are supposed to sketch a picture of what NaCl looks like when it's dissolved. Well, we know that the NAs will actually split up from the chlorine ions. So I'm going to draw a few sodiums, and then I'm going to get a green, and I'm going to draw some chlorine ions that are all separate from those sodiums. And then in between them would be those water molecules surrounding each of these different ions here. So I'll just draw some of these. And then we're going to use Odyssey to actually take a look at it. So it says to open the demonstrations, complete list, solutions, how do salts dissolve in water? And when you get that, it looks like this. And if you change it from space filling to the multiple styles and you click at the bottom here, you can see that the ions are splitting up from the bottom and they're going into the water molecules. We can kind of see what it looks like with the space filling too. See, they've separated and now they're mixed in with the water molecules. Take a screenshot of what NaCl dissolved in water looks like and paste it here. So I'm going to go back to the multiple styles because it's a little bit easier to actually see the separate ions in this one. So I'll take a little screenshot and post that here. Ooh, I did not like how I did that. Let's try this again. There we go. Thank you, OneNote. And then we're supposed to draw a reflection of how our sketch compared, or a type of reflection. So for mine, really, mine was similar, but in the Odyssey model, there were way more water molecules surrounding the ions. All right, let's get to the lab. How does the temperature of water affect the rate of dissolution of NaCl? That means how fast it dissolves. So this you need to do on your own, but using an if, then, because format. So for example, you would write if the temperature of water increases, then the rate of dissolving, and then you would choose increases or decreases depending on what you think, or stays the same, and then explain your reasoning. So because, so you need to write a little bit more here. And then get out your supplies. 1 cup. Clear cups work best, but really we can make anything work. 1 regular spoon like you would eat cereal with. Salt, any type is fine. Water, and a timer. If you've got access to a microwave and ice cubes and some sort of thermometer, that's awesome. If not, no worries. Today we're going to be manipulating the temperature of the water. And the responding variable is going to be the time it takes for the salt to dissolve. We're going to be using 6 grams of salt each trial because 1 teaspoon of salt weighs 6 grams. We don't have to be perfect here, but we're going to be consistent. That's what controlled variables are all about. We'll use the same amount of water each trial. Notice I'm not being specific because if somebody doesn't have a measuring cup, I don't want that to be limiting. So if you really want to be exact, then you can get out a measuring cup and that's awesome. Otherwise, at school we would use graduated cylinders and maybe we would use 100 milliliters of water each time, something like that. But again, just fill a cup as if you're going to have a nice drink of water. And then we will stir at the same speed each trial. So you just want to be consistent with your stirring speed. Consistent. All right, now we're going to do the lab. And I just did this. I'm sorry, this won't be on camera, but I'll kind of talk you through what I did on the side. So first, I got some ice and I put it in the bottom of my cup. And then I filled the cup with water. And I got my cell phone ready to start timing. And I took the temperature of the water, the ice water, and it was 11.7 degrees Celsius. I added my teaspoon, my little spoon of salt to the water and I started stirring. And it took 33 seconds for it to fully dissolve. Then I rinsed everything out and I filled the cup with about lukewarm water this time. So it was just like room temperature water. So I took the temperature of it and it was 26.8 degrees Celsius. And that took about 23 seconds to dissolve. Then I let my tap water run as hot as it could possibly get. And for me, when I took the temperature, that was 39.8 degrees Celsius. And that took only 10 seconds to fully dissolve. So now we're going to be calculating some rates. So again, my temperatures, I'm just going to record in my data table, were 11.7, 26.8, and 39.8. And the time that it took, 33 seconds, 23 seconds, and then 10 seconds. Now to calculate my rate of dissolving, I did 6 grams of salt divided by 33 seconds, and that was 0.18 grams per second. And for this one, I took 6 grams divided by 23 seconds, and that was 0.26 grams per second. And last, I took 6 grams divided by 10 seconds, and I got 0.6 grams per second. So you can see it's going up and up. As the water got hotter and hotter, the dissolving rate increased. Now, pause if you haven't done this yet and write out your conclusion. And then you're going to be putting it into a Microsoft form. But let's type off to the side here and answer these questions. So pause the video, do your own, and then you can check with me. So first one sentence answering this question. How does the temperature of water affect the rate of dissolution of NaCl? So we'll say, as the temperature of the water increased, so did the rate of the dissolution of salt. Okay, I got fancy with dissolution of salt. Now we need to cite specific data. So when the water was 11.7, and I'm going to insert a degrees symbol, the rate was 0.18 grams per second. And when the water was heated to 39.8 degrees Celsius, the rate increased to 0.6 grams per second. Notice that I'm just citing the lowest and the highest data point to show the trend. Reasoning. Why does this make sense? As the temperature of the water increases, the speed of the water molecules also increases, which means they collide more with the salt, pulling it apart into its separate ions. That's it. So then you'll copy that, put it into the Microsoft form for easy grading. All right, hopefully that helped.